Welcome back to Talk Local here on Rogers TV Cable 20. I'm joined now by Steve Holmes, the past president of the Royal Astronomical Society of Canada. And we're talking about an out-of-this-world accomplishment. And yes, that pun's intended. Thank you for joining us tonight, Steve.
My pleasure, Kathleen. Thanks for inviting us.
So yesterday, robot probe Philae landed on Comet 67P. And this is the first time we've been able to successfully land on a comet. This has been headline, front page news. Why is it so important?
It's taken us 10 years to get to this point, and originally the mission was designed going back to 1993 because there are a few unanswered questions. We have theories, but we don't have the hard data to know which theory is correct. By going to this comet and by actually taking, on-the-spot observations and analysis, by sending that data back to Earth, it will give us a chance to look at these theories and say, well, this theory predicted it, that's correct. This theory did not predict it or predicted something else, it's incorrect. Why is it incorrect? Why is this one correct? By the time the data gets sifted and everybody analyzes it, you'll have a much better idea of the truth. And the truth in this matter is, what was the early solar system like? What were the planets formed out of? What were the comets made from? We understood what it was, but there are two main theories about the early Earth. One was that because of all of the heat, the volcanism, the Earth was molten, the entire planet. The one theory is that the Earth ended up after that, when it cooled down, it was basically a dry rock.
Oh, yeah.
And the theory up until now has been, or at least was put forth about 10 years ago, is that the water came from the comets, and that all our oceans are basically hundreds of millions of comets that struck our Earth about 3.5 to 4 billion years ago.
Wow.
So that's one theory.
Okay.
But the other theory is that the water came out of the Earth as the minerals were basically cooked, that water would be chemically released from within the rock crystals, and that's where the oceans came from. But since we don't have any of that pristine material that the early solar system was made from, we don't really know which theory is correct. We may have inklings, but we don't know. By getting a sample of this pristine material, it's been locked in a deep, deep freeze for about 4.5 billion years. We'll have a good handle on it, not only chemically, but also the isotopes that they're made from. It will tell us where this body formed in the solar system. Has it migrated in from further out, or is it migrated out from further in? And of course, the big question, I don't know whether we'll be able to settle at this mission, but are there amino acids in the ice of the comet? There have been some tantalizing indications that amino acids, the basic building blocks of proteins and life, that one of the theories is that the Earth, when it was bombarded by all of these comets, and comets are almost entirely water ice. They're basically snowballs with some organic and dusty dirt in it. The theory is that the early oceans would have been absolutely contained a lot of amino acids already, which would have perhaps kick-started life. And if that's the case, and we think that our comets are fairly typical of other comets, then what ends up happening is that on the other worlds, they're probably also getting bombarded by amino acid-laced comets, and life may be a lot more widespread than we think.
Okay, so break this down for me like I'm in grade 1 science.
Okay.
What is the difference between a comet and an asteroid? Is there a difference?
An asteroid tends to be rocky.
Okay.
You would think of it much as you would any kind of a mountain or a rock. They tend to be silicates. A lot of them are heavy amounts of iron and nickel in them. A lot of meteorites are magnetic, for instance. You can find them in fields. You know it's a magnet because it's magnetic, or a meteor because it's magnetic.
Okay.
But there are other ones called carbonaceous chondrites, which are more organics, and we found some traces of what appear to be amino acids to us inside these comets. But we don't get very many of them. They're extremely rare. And of course, they've also been cooked by the passage through the atmosphere, so a lot of the volatile things have boiled off on the way through the atmosphere in that fireball as they come down. But even within it, we found materials that intrigue us. And to be able to see them in their original state inside a comet, where again they've been frozen for 4.5 billion years, would give us an absolute, it's as if we had a time machine to go back to the formation of the solar system and just see what made it all up.
Isn't that fantastic?
It is amazing. It is really amazing.
You know, and now they spent €1 billion on this whole mission. Is it worth it?
Well, you've got to remember, it's a 10-year mission.
Yeah.
So you're talking about maybe about 100 million euros a year. A lot of that is for salaries for the scientists that are involved in this. The actual craft itself is not that much, but it is a big chunk of change. But again, we learn by testing the limits, engineering-wise. Part of the space program going forward has, from NASA's perspective, and President Obama laid out the roadmap there, where the intention is long-term to go to Mars, but before we go there, we need to look at near-Earth asteroids. So there are trips that will be planned to capture reasonably small asteroids, maybe a couple of meters in diameter, in near-Earth orbit. Move them to orbit the moon, and then send the Orion spacecraft that they've recently, they're going to be doing the first shot. I think is it this month or next month? Unmanned, but they're going to shoot it off. But that will then go to this asteroid in orbit around the moon, and look at it initially for science, but long term they're interested in whether or not the minerals that they find on some of these nickel-iron meteorites, there could be lots of things like platinum and gold and rare earth materials that we might be able to mine from them at a very economical rate.
So now, is there a way that we could pull this comet, like, you know, would we have to mine it in space, or would we be able to pull it into Earth, or how would we go about that?
Well, the initial technologies only allow for small objects. So you would be looking at a small rock, basically, that would be transported. It would be something, there are a number of asteroids or rock bodies that actually orbit the Earth now. By putting small ion thrusters on them, these are ones that burn, they use very little fuel, but solar powered. They shoot it out and you get a reaction from that. But they can run for many years, and slow, steady thrust. Over time, by programming that thrust and the direction that it's going, you can nudge that asteroid where you want it to go. But the 67P, the comet that the probe is on right now, is far too big for any technology that we have to move in any significant way.
Because people were saying that, you know, everyone's going to say different things and bring in pop culture. They were saying it's like Armageddon. Are we going there are we trying to destroy this comet? Are we trying to move this comet? But you're saying we're just using it for research right now. It is,
yeah, we don't have any ability to move it.
Yeah.
We don't have any rockets. In fact, this mission itself was they had to come up with a short way to get there, but the fastest way would have been to fire rockets all the way there and then decelerate when you get close. They could have probably gotten there within a year or so instead of 10 years, but the expense required to boost, to lift rockets up into orbit and then attach them to this probe and then to send it on a high speed, and you remember you've got to have the same amount of fuel to slow down as you do to accelerate. So we burn half your fuel to get there, half your fuel to slow down and go into orbit around this comet. And it was just judged just too expensive and beyond our current technology to do that with in any practical way. Yeah. So that's it's strictly a science mission, but the data that they may be getting back is breathtaking. Of course, you know, there's been a bit of a snag on it that may in fact be in a bad position.
Yeah, I heard that. Now, you know, they were saying that it has possibly landed in a shadow and it's relying upon solar energy. Can the comet move? Can this probe move to get back into the line of the sun?
It can, and there are a number of options, and as you can imagine, they're in Darmstadt, Germany, they're going to be looking at everything, all of the possibilities. They have batteries on board, which I believe will last them until Saturday.
Okay.
But beyond that, it requires solar power to recharge its batteries, and the recharge is only getting an hour and a half of sunlight where it is right now a day.
Oh boy.
Not enough.
No.
So at some point, Saturday or later, it will run out of juice. So what they plan on doing is run the batteries as close as they can safely get them, and get all the science they can out of the situation they have right now. And then they'll perform a maneuver which is basically going to flip, bounce the probe out. It's up against, with almost on its side, with one leg up, what appears to be a cliff or a very tall boulder. But because the bottom of it is not in contact with the ice of the comet, it cannot use its drilling tool, which would then bring the material into the instruments inside the comet, which would allow them to do, you know, the really detailed analysis. So that might not happen, I don't know. And I'm not sure what they're going to be able to understand about the surface of it without the drilling.
Yeah.
But I didn't know until yesterday that there actually is, because where it's sitting on the comet right now, the mothership is orbiting. It's going around the comet. So at one point, the comet is right between the lander and the probe, the orbiter. There is a plan to use microwaves, to send microwaves down at the and basically do an ultrasound on the comet as it's going around. By measuring the microwaves as they're disturbed going through the comet to the probe, they'll be able to determine whether there are voids inside the comet, the density at various places within the comet, and more of the overall structure of the comet itself, which we don't have a clue about.
Now, how far has this advanced us? I mean, you're watching images now on TV of the amazing shots that are coming back from this robot probe. How far has this advanced us in space exploration?
At the moment, the technology is huge. You've got to remember that this was technology that was current probably about 15 years ago, because at some point they have to cut off and they have to stop changing the spacecraft.
Yeah, and send it out.
Exactly, it's about time. So that was a long time ago. Obviously, we've made some big advances since that time. So a probe that would be designed and sent today would be far more advanced. But with what we did have on that probe when it went, it can answer all of the big questions. It certainly give us, as I mentioned, whether or not the the early solar system was dry or wet. These are all questions that we'll get a better answer for, and be able to show which theory is correct and which one isn't. That's the beauty of science, is if you can't prove it wrong, it's not science. It's philosophy.
Very true. Now, the European Space Agency was working with a few Canadian companies. You know, did they ever approach the Royal Astronomical Society, or did you know anyone from Canada that assisted in this mission?
I do not, personally, no. But I know that there are a number of universities in the area that do get involved. I know the University of Guelph has been involved in past space missions. I can't speak to the universities in town, but I know Guelph was involved in past missions.
Great. Now, we're going to take a very quick break. Coming up, we're going to talk a little bit more about a few conspiracies that have come out about this robot probe on Comet 67P. Be sure to join the conversation. Tweet us at TalkLocalWR. You're watching Talk Local on Rogers TV, Cable 20. Welcome back to Talk Local on Rogers TV, Cable 20. My name is Kathleen Campbell-Conlon. I'm joined with Steve Holmes, the past president of the Royal Astronomical Society of Canada. We're discussing the robot probe Philae and the landing on Comet 67P. And we want to hear your input. If you have any questions for Steve, let us know. You can tweet us at TalkLocalWR. Now, one thing, Steve, I have to mention, it's starting to surface. People think this is a conspiracy. People are starting to say that Comet 67P is an alien spacecraft, and that us landing on this spacecraft is great. It says that these this other forms of life, like you mentioned, forms of life are allowing us to be on their craft. Is there any weight behind this?
It's 67P was initially discovered in 1969, I believe.
Okay.
And it's been followed since that time. It hasn't shown any signs of propulsion in that time. It's been falling with, just a free orbit around. It's just moving on, just falling basically around the sun on a regular basis, and its orbit hasn't changed. So yeah, unless the aliens are quite comfortable in sitting still for 30 years at a time, it seems unlikely it's a spaceship. But
maybe they have a different, isn't time different in space anyways?
Well, not at these speeds. Einstein talked about it at higher speeds, but at regular speeds that we experiencing in this, no, there's no time dilation effect.
So people are saying that this rock, this comet, is actually emitting a song. From what I've been reading in the news, that there was an email to the European Space Agency that said, we know what this is, and there's a mystery song that's coming out of it, and we're going to interpret what it's trying to say to us. Would you be shocked if you found out that there actually were life on there?
Completely shocked.
Yeah.
Yes, I would think that would be probably not a likely scenario, but I'd be interested in hearing what the song is.
Definitely. Has
it been released? I don't know, but
you can buy it on iTunes.
it's the old thing where no astronomer has ever seen a UFO, so I'm not sure that we can really draw a whole lot from that. It tends to be, I think, more fanciful thinking than anything. I
think that's the great thing about astronomers is it can't be an unidentified flying object because you're an astronomer and you can identify that flying object.
Well, unidentified flying objects happen all the time, but they're just unidentified.
Yeah.
It's quite a leap to go from an unidentified flying object to an alien spacecraft from a civilization, dozens of light years away. There's a bit of a stretch there. I think it's probably at the moment, let's just stay with unidentified.
Now, you said that this comet has been on our land, on our watch since the 60s.
Yes.
Does it ever pose any threat to Earth?
It doesn't come within the Earth's orbit. It comes close to the Earth at times, but not this particular orbit. But it goes out as far as Jupiter and comes back in within the orbit of Mars to close to Earth. But it doesn't pose a hazard for us. This particular comet does. But of course, there are lots of other comets.
Yeah.
Some are periodic. This one is a periodic comet.
What does that mean?
It comes around on a regular basis.
So we're going to see it every now and then?
Yes, every few years you'll see it, or not see it so much, but it'll be closer it'll get close every few years.
So its orbit wouldn't be something that would be circular, it's more of like an oval?
Correct, it's what they call an ellipse, yes, absolutely.
Now, we were talking during the break, you can't see this comet, can you?
No. It is not visible from Earth telescopes, other than the fact that it's a point of light. It wasn't until the spacecraft was approaching 67P that it realized that it was not an odd-shaped hunk of ice the size of a mountain, but in fact two what appeared to be roughly snowball-shaped balls with a bit of a neck in between them, which they're referring to as a rubber ducky kind of a shape to it. But basically two objects together, and this is just gravity. These two balls just gradually floated close to each other and just stuck a little bit. But it is a fascinating. One of the ones I'm still trying to get my head around on this probe is that they released the probe from Rosetta at an altitude of 20 kilometers. And they dropped it on the comet from 20 kilometers. There's not a whole lot of gravity, so it's like watching things in slow motion. But they estimate that the comet bounced close to the Philae probe on the comet bounced close to a kilometer away from where it was supposed to land.
Okay.
That was unexpected. I don't know if it's some kind of an elastic property of comets that we're not aware of. I'm trying to be a little light about it, but it's odd. It seems that it was unexpected that it would bounce so much. So that by itself probably tells somebody a great deal about comet structure.
Yeah, that it has this different the material. That's amazing. Now, Really quickly, before we wrap up the show, you did mention Mars. I'd like to know, while I have you here, what do you think's on Mars?
Mars appears to be a relatively dry planet on the surface.
Okay.
It used to have a thick, warm atmosphere. We know that at one point there was liquid water flowing on the surface of Mars, which is impossible today. So in the past, it appeared to be warm and wet. It got cold and dry when it lost its magnetic field, probably about 3 to 4 billion years ago. It's a much smaller planet, so it basically went solid all the way through. The Earth has a magnetic field because we have an iron core that spins at a different speed than the outer planet in a different angle. And that protects us from a lot of the harmful radiation from space, but Mars doesn't have that. So the radiation that isn't stopped by the very thin atmosphere just pounds the surface. And it is not anything that we know that could live on the surface right now. It would be killed by the radiation. But with time and with effort, and probably we're talking thousands, maybe millions of years, Mars could be built back up into a warm place. They call it terraforming, and it is a possibility. It's the only planet in the solar system where humans have a chance of actually living on the surface.
Wow, in millions of years.
Yes, possibly, yes.
Well, over the next few days, definitely by Saturday, we're going to learn more about this probe. Thank you so much for joining me on the show tonight, Steve. I think we've all learned a lot more about comets and about what's happening over there. And I think we're going to learn a lot more even just from Comet 67P. And it's just fascinating. I'm so thankful you were here to explain this to me and to all of our viewers here. I'd like to thank my earlier guests as well. I'd like to thank Mayor Doug Craig of Cambridge and also Kitchener Mayor-elect Barry Verbanovic. I'd also like to say thank you to all the volunteers here who have helped to make this production, and to you, the viewers, for keeping us here and interacting with us as well. Thank you so much for tuning in. My name is Kathleen Campbell-Conlon. You're watching Talk Local, Waterloo Region on Rogers TV, Cable 20.